Hello and welcome back to the channel where we are building a video game from scratch using Love2d and Lua. So yesterday we started building out our mage castle here. So we've got the little goblets of fire, we've got a mage castle that we can walk inside of, and then also go inside of, come out. We got a rickety bridge leading up here, so mage's castle's like super tall, comes up here. This will be the first starting area in the game, and I think what we're working on is if we extend and walk out towards the desert or towards the ice mountain, we want there to be barriers because in the demo these places aren't available just yet. So as we come out on the other side of this dungeon, if you go too far, you know, here's an example of what like snow would look like, but over here, if we go to the desert, we want our particle system of sand to start blowing, and then if we go deeper into the desert, it's going to be, you know, really intense sand, so that it kind of like blocks us from going too far into the desert. So it's kind of like an artificial way to kind of just like block off the biomes that we haven't developed yet, like the desert. So I don't know how we're going to do the particle system based on the scene, but we can maybe just check how we're doing the particle system, period. We have these classes like snow system, sand system, and the sand system is a class object that has a particle system from Love's particle system generator that we do this set linear acceleration, emission rate, colors, update, you know, life cycle, all that stuff. So if we look at our sand system, we got this wind angle that kind of changes, so it looks like it's kind of like blowing. It updates and then it renders. And then if we hold down 5, we can see the sand wind angle. All the render is doing is just rendering the particle system, you know. So all the particle system is for sand, it's an 8,000 particle system. Got a lifespan, a minimum angle, emission rate, all this kind of stuff. So what we need to do is for this sand system, this is an object, so we have in our scene here an initialization in a field called .SandSystem. Then we have an update, which we need to run if we want to see our sand system. And then we can search for the last render for our sand system. That should give us our sand system on screen here. So this is our sand system. It's just got, you know, sand blowing in. Now this is in the scene, so it's a little hard to see. Now the scene is different from the map because the map is like a scene we're looking at. So like I define these things like map is one quadrant of thing that we're looking at, but a scene is what's holding the map as well as the next map, so it can render both of these things. So the scene is kind of like two things. It's kind of like the current map as well as the next map. So the idea here is that this particle system is kind of slopped away into the scene, which means that if we go from map to map, it doesn't translate because only the map is being translated by this adjacent offset, right? That's what gets us this illusion of scrolling. But you can see that our sand system, our particles aren't scrolling with the map. That's because they exist in the scene and not the map. So I'm trying to wrap my head around how we can do this, and it's like, you know, we need to make sure the particle systems are different colors than the actual colors of the sprite so that we can see each particle, because it's like it's harder to see You know, it's easier to see the sand here when it is a darker background versus the lighter background. So it's like, I don't think I want to do more than 8,000 particles for the sand system, especially because right now we weren't updating this every frame until we turned it on. So that's basically like 8,000 particles for our game to track and calculate the update for. 8,000 of them when we don't necessarily, we only need the sand system in a couple locations and only localized to the sand areas. So I don't exactly know how we're going to do this, but ideally what happens is there's no sand particle updating or rendering unless that given map has a particle system. And then if that map has a particle system, then we can start to update it and render it. But as we scene transition, we ask if the next map we're transitioning into has a particle system applied to it, and if it does, go ahead and keep track of it so we can update it and render it. If it doesn't have a particle system, then go ahead and just stop updating and rendering any particle system in our scene. But the hard thing about that is our game is built of 100 scenes. We could initialize all of the particle systems. You know, we can say there's a particle system field on every scene, and it starts off as nil or empty. And until we kind of map declare it to have a type of particle system, as well as some parameters like emission rate, wind angle, all that stuff, until we initialize it to have those values, it has nothing. So I'm trying to think if it would belong in the scene or the map. I like the idea of it being in the scene because it can make for some smoother transitions, because man, I really don't know what to do, because ideally, like, let's say from a transition from here into the sand, there would be no particle system, but then as soon as we switch here, it'll start updating and spawn these particles. But then if we walk away, those particles, I guess the particles would stay on the map, huh? Because they probably wouldn't follow us over here. So it does kind of make sense to put them in the map. Oh man, it's tough because we have this issue where when we put it in the map, there's like, what happens with this particle system in Love2d is, like, let's say we have 200 particles spawning, and let's say we walk to a scene and start to update this particle system. It has to spawn all the particles, then the particles have to go through their life cycle, which we set like a time for, and the new ones don't populate until the previous particles are cleared. So what we end up getting is like a burst of initial particles, and then they update, and then after a second or two passes, then we start to get a continuous flow as the old ones die out and the new ones spawn in. But this is because when we put it in the map, this would kind of initially spawn, trickle in, and then when we would scene transition, it would do it again. It would be like, okay, well, now this is a particle system, so let's do the spawning again and then update. So it never looked consistent, because at least when it's in the scene, if we walk from scene to scene, it's consistent. It looks very contiguous. Yeah, so I don't know. I don't know what the approach is here. Because we would want it to be adaptive. I think we want it in the scene, and we want it adaptive. You know, I would like if the scene takes note from the current map about what particle system params that we need, and once we finish the scene's transition, it gets those params, updates the current particle system to be appropriate, where if we don't map declare any particle system, then we would then trigger a set emission rate to 0 and then particle system clear, or we just particle system clear right away. I think that's what it is, clear, to just like get rid of the particles completely, and then we would just have to reinitialize it if we're transitioning into a scene that has a particle system and that particle system is already initialized. Oh my god, it's a lot. Yeah, because we kind of want to adaptively change this particle, because it's like we want it to be like a little bit here, stronger here, and then so strong you can't even walk past the barrier here because there's just so many. So we want it to be adaptive, and it needs to adapt based on the current map, but it needs to exist in the scene so we get that cohesive, fluid update. So I think that's what we're going to try to do. But I am very intimidated by that. Probably because I'm tired. Yeah. Well, let's try it. Let's just try it one piece at a time. You know, can we have a particle system table for each map? Then once we begin transitioning into a scene, into a next map, we can say, okay, well, if we've got a particle system declared in the map we're transitioning into, then we want to put it into this particle system table in our scene and start updating it so that we get the appropriate particle system. Then if we transition into a scene without one, then we need to flush our particle system out of our scene. Yeah. Because we've got a snow system, a rain system, a sand system, and a lava system. And it doesn't make sense to update and render, or, it doesn't make sense to update them every frame regardless of what scene you're on. It just doesn't make any sense. So I think we want to go with this adaptive system so that the dot particle system in our scene could be of type sand or rain or anything like that. So yeah. Oh my gosh, man, I am so tired. So I think that's the game plan. We'll let's see, because right now what we have is a system field, a particle system field for each of our particle systems, but what we really need is a particle system field to hold any type of particle system, and whatever type of particle system we have, we need to know, it needs to be a class in itself, because they have these unique parameters depending on which particle system it is. So if we go into the sand system, we can look, we've got all of these different variables here. We've got the emission area, the linear acceleration, all this stuff, the colors, update and render, versus a lava system, which has different stuff like a wind angle and a lifespan and a soot emission rate, different stuff, right? So I think I think we want to use. Yeah, okay, so I think what we need to do is create some methods inside the particle system classes to reset initial values, because what we need to do is give us a particle system field in our scene that holds whatever current particle system is. It could be any of them, but then when we update it, you know, it'll update their positions and stuff, but then we need to tweak that live, like, oh, it needs to be more emission rate because we're getting deeper into the sand ecosystem, or it needs to have a 0 emission rate because we've just transitioned into a map without any particle system inside it. So if we set these values to 0, we need to be able to reset them back to their original initialized positions so that it can look normal again when we go back in. So I think we want a particle system here, and we'll set it to an empty table so it doesn't have anything just yet. I want to make sure we don't have a particle system in our scene already. Okay, we don't. Okay, so let's test something. Let's say that we want to table.insert a particle system into our particle system table, and we'll insert into our particle system a value of this sand system. So now our scene's particle system is holding that instantiated particle system of sand, which that's all I'm testing right now is just one sand system. So in the scene here, when we go to update and render the sand system, we were going to turn this off so that we don't see it, so that we can test that our particle system field is working. So we're going to go into our sand system render, turn that off, and what we want to replace it with is, okay, we go into our particle system table. I don't know if we have to do index 1. Let's see if we just try to do this and just say, we just render the object that we stored inside, which is essentially the same thing as this, just self sand system render. And then we need to go into the update, and instead of updating our sand system, we would say go into our particle system, run the update method with delta time on our sand system that's inside our particle system, because we inserted it here in the init. So now we've changed from updating our sand system to updating our particle system, and our particle system can hopefully take in any of our 4 different types of particle systems. So let's see if we see it. I have a feeling it's the 1 index there. Let's see. Can't update on scene 185. So scene 185 can't update. Yeah, I think we want this. We say go into the table. Because it's an empty table, when we insert into it, it puts a table inside the table, so we need an index in the table to actually update the object that's in there. Same thing with the render. Same thing with the render. Yeah. Yeah. I wish there was like a null coalescing operator for that. Okay. There it is. Now do you see that initial kind of like burst of particles there, and then it becomes kind of continuous, right? So that's what I'm talking about, where we don't want it in the scene, in the map, because if it was in the map, it would reset every time, and it would do that blurt every time. So that's why I like putting it in the scene and not the map. Okay, so we've got a particle system. Now we're rendering the particle system, so now like what we can do, I think, is be like, well, if instead of putting sand, if we wanted to put in snow into that particle system, all we have to do is insert that, and then we've got the snow. So we can kind of just decide which particle system we want in there. So the next step is to both create methods to reset these, but also add some additional checks into the map. You know, we need to define on the map which scene has what particle system. So in order to do that, how we've been doing that sort of stuff is we have what's called a map declarations table, and we have a whole bunch of empty tables. And what that looks like is like whatever field we want, we give it. So this 2D array here is like every 100 scenes of our 10 by 10 overworld map, right? And I call them scenes, they're really maps. Yeah, that's why they're in the global map table. But we want to say that, well, every map is gonna have a particle system. And look at this, we already have a particle system table for it. So do we do anything with this piece systems? Because it's kind of cool, we already did that. So we do already have that, but we're not doing anything special with it, I don't believe. So if we do a piece systems check, we want to see if anything in the map is being indexed. So any sort of global map dot piece system being drawn. Now the dot piece system here is from the class. That's totally different. We do. Oh, look at this piece system release. Okay. Oh, we have something like this. Oh, piece system. Okay. So I think this piece system field is actually for the particles for the spellcast, because we're doing this for a 1 where I gets 1,3, which I think that's because we have a total of 3 spellcast elements for our Flamma if it's maxed out. So our P systems is already being used for the spellcast element, so we'd probably want to change that. Yeah, we'd probably want to change that. But yeah, look, well, let's see. Yeah, it's a P system. This is in the falling chasm state. This is something else. Okay, so let's try this. Let's go into each map in our global overworld, and we're going to say that there's going to be like an environment particle system or something like that. Like, yeah, an environment P system, environment. We can call it weather. Okay, so weather, there's a weather field on every single one of our maps, and it's an empty table right now. So what we're going to do, yeah, the idea here is like, instead of doing the init table.insert into the, where did we do it? It's how we're getting the snow system now. Right here. So instead of going into the scene particle system and putting in a snow system, what we want to do is go into the scene views.particle system and insert the object that is in the map declared .weather table, because we don't know if we want to insert sand or snow or whatever until we're transitioning into a scene that has one of those predefined things. So let's try to do it. And what we'll first try to do is, we know, once we start the game, we have like an init, but I don't think I'm worried about the weather system on the init just yet. I want to do it upon a scene transition because I'm mainly worried about just updating these values so that they exist in the scene, so that when we transition, it's still in the overworld of the scene, but we can adapt its emission rate or reinitialize its emission rate. Because if we go into a scene without a particle system, we need to take the current active particle system and slice or release the particle system, which deletes all the particles because they change as you walk. So we need to just figure out this update. So I think what we're going to try is in a begin shifting. So begin shifting is what happens when we shift the screen, right? Now if we begin shifting, we have this spellcast entities. I would think we had, see how we have this particle systems release method for the current maps particle systems. So this is different. This is the spellcast particles because the spellcast elements exist in the map. Let me think this. Yeah. Because when we're scene transitioning, we don't want the particles to flow. Let me see what it looks like. Cuz we have oh god, what happened? We crashed and I can't even see the error message. Attempt to index nil value 185 on the scene, so let's just go fix that. Particles, system 1. Oh, we took out the table.insert. So well, let's just get that back so that we don't crash. Okay, so yeah, look at the particle system here. If we put on our element and start spellcasting, yes, the element particles stay in the map, which makes sense because it's like we leave. The fire hasn't been to where we're going. If the particles stayed in the scene, then our blue particles from our fire would end up at the top of the screen when we transition there. So our element particles are remaining in the map, where our weather particles are remaining in the scene, so that it looks fluid for the weather, but also it looks realistic for the spellcast. So I think that's right. So yes, we want to take out, yeah, we want to, at the end of the day, we need to go into our scene view particle system and insert a particle system based on the map declaration of our weather table. But we also need to make sure that if there's no particle system in the scene, that we don't crash, that it handles an empty particle system. So when we go to, see, this is wrong. Let's see, the scene, particle system table. Yeah, we'd be inserting it to the particle system. So let's do the particle system on our scene. Yes. So here, this is a very crashable line, because if there's no particle system in the table, if the table's empty, it would crash because it's trying to update a nil value. So we have to ask, you know, I wonder if there's a better way to do this in Love2d, but I've been doing it like this, where we say like, well, as long as the thing that's in index 1, basically the first index of this table, as long as it's not nil, go ahead and update it. You know? And then we want the same thing for the render. So particle system render, we want to say, well, if our particle system at index 1 does not equal nil, then we want to go ahead and render it. So now we shouldn't have that crash if we take out the line where we table.insert the particle system. So it is commented out, so we shouldn't crash now, and we shouldn't see snow. Cool. But if we turn it on, we should get snow. Yes. Okay. So it exists in the scene. That's all good. Now in our map declarations, we have this new weather table. So let's see what line we're at. What scene? We're at a map 9-2. Map 9-2. So I would like to say, you know, we can put weather here. Something like that a map 9-2.weather. What up, Squinch? How's it going? How's it going, dude? I want to say that this weather is going to get this line that we used to have right here. So instead of putting it in the init, now we're going to be putting it in the map declaration so that we can update it as appropriate. So we're going to table.insert not into the self particle system, but into the scene views particle system, and not into the snow system, but the scene views snow system. That's just where we put them. We put them in the scene. So we have to insert it there. So we basically want to say, how would we do this? Because it's like we basically need to, what we need to do is, like, if we're transitioning into a scene with a particle system, because basically what we want to do is say, like, that the weather table has an index. We say, like, the well, we can, let's see, you know, we want to insert a value into this table, and the list is this weather table, and the value is going to be something like a string of saying, like, what particle system goes in, you know. So at this point, you know, if we say the thing that's in our weather table on 9.2, which is our current scene we're spawning at, if that has a string, a valid string of a particle system, then go ahead and table.insert into the scene the particle system that corresponds to that string. If we're shifting into a particle system, into a map with a particle system with no string, no initialized value for this, then we would set our emission rate, or just release the particle system so that we stop seeing it once we finish that transition. So it needs to be something like this, but the table.insert into the particle system needs to happen into the begin shifting method for our scene. So if we go here into our begin shifting, in our scene begin shifting, we want to do something like, I think we want to do something like this, where we can say, let's check, you know, we can call it weather, and we can say, well, if the new map, right, because we just, yeah, it's actually the next map. So if the next map, has a weather field that is a valid string, then we need to insert the corresponding particle system into our scenes particle system table. So, you know, if our next map, now is our next map, let's look at what our next map is. Is it the actual instantiation of map object? Once we begin shifting, our next map is what? I don't see. Next map, okay, right here. So once we decide what transition it is, the next map is a map instantiation of... Dude, why are we passing in spellcast count into the map? I don't know. Okay, we're I think we're good. We're good. We're cool. We'll be fine. We're cool. We're focused. Yeah, next map is a map object. So this should... Well, let's see. So begin shifting, right? Now, the map... See, and this sucks because the weather table isn't in the map. It's in the global map table, which is just defined differently. So yeah, it's a little messy because like I'm trying to think, you know, it's like our 2D array of our global map table is just that, a 2D array, but then we have a bunch of fields of different stuff for current map or next map. So when we're trying to do a begin shifting and determine what particle system insert into our scene, we have to go into the field. We'd have to go into our global map table at our next map index. But we have this current map row, current map column. I don't think... Do we have a next map row, next map column? It's just that... What the heck, dude? Let's look at our map. Do we have like a next map? No, we don't. We have a current map. Current map column. Okay. Okay. So we might have to do it on a finish shifting because the only way we have access to the index of the next map is by once we assign the next map into the current map, we can then touch it that way, but I don't exactly know if we can do it on the begin shifting. We have a current map. Okay, so let's see what happens when we do a begin shifting again. And just see, not in our map, in our scene, begin shifting. Okay, so we have an offset, but not a you know, row and column. Now we kind of have, you know, we have it here, right? We have this row +1 if we're doing a down transition, right? So we have access to the correct index for our global map right here. So maybe we can do it on the event trigger here. But also, we also increment the map row in our scene. So we could do it here using the map row or map call or map column. Map column. Okay, so we do kind of assign that parameter into a different field in our scene. So we should be able to do that with a map row map column field. So map row map call is what we want to go into, and we're going to see I think what we want to do here is say if the map global map at the index of self.map_row, oh my god, self.map_row self.map_column, we want to kind of, you know, this is once we begin transitioning, and we only begin transitioning if we event dispatch a scene transition, and the scene transition is what updates the map row map call to be the index of the next map as it triggers, as it you know, transitions in. So we're trying to go into the field, into the weather field of this, because this is our scene that is coming into view. And we want to say, okay, well, if the thing that's in that weather table, if the first thing, and let's just try it for snow, because we know we inserted a snow. a snow table, snow string. We say if the value of the thing in there is equal to snow, then we're gonna table.insert into the scene the particle system of a snow system into the particle system of our scene. So this is close. We need to catch the nil, because right now we spawn into this scene, but when we walk anywhere, we'll try to index the weather 1, which there's only 1. So I guess we should put this 1 above us if we want to test this. So in our map declarations, instead of putting it in 9.2, we're going to put it at 8.2, right above us. But then we also want to only do this check if there is a string in this field table. So like we want to say, you know, we'll say if our if the dot weather index 1 does not equal nil, if it's not an empty table, then we're going to go ahead and insert it. If the thing that is in there is a snow, we're going to insert that snow system into the scene. Now this won't delete it, but I'm hoping it'll insert it if we go up. So we had it updating, right? So like, let's see. Oh, yeah, dude. That's it. So it's like we triggered the snow to exist in the scene if we go into a map with it on there, which worked. It worked. But if this thing, if the thing we're going into is nil, we need to release the particle system to get rid of it. So if it is nil, I think we want to go into the particle system and release it. So we would say go into the particle system table. It's actually not self, it is actually, yeah, self would work. I think if we do this with self, it should give us the same thing. Let's see if it still works. So like no snow system, but if we go into 8.2, there we get the snow. Cool. Now, yeah, it just updates and lives there. So we're gonna say, well, right now the only weather table that has anything is the one right above us at 8.2. So we're gonna say if the thing is nil, if there's no weather string put into that table by the time we're beginning a transition into that new map, then we want to go into our scene's particle system and go ahead and release the particle system, which is a method on the particle system that just deletes it. Deletes all entities of the particle system, I think. So there it is. So now if we scene transition into another scene, release is nil. Okay. So release. Do we have to do the old 1 indexing to get it? Okay, that's cool. Shit. Okay, let's look for, I mean, we're doing it somewhere. Systems at the index, release. Okay, yeah. That's how we do it. Yeah, because look, we're doing the same thing where we index into the particle system, go into the index, which is 1, and then release, and then run it like a method. So that's what we're doing. It's just crashing. Now, the particle system itself, yeah, it's like, since the particle system, okay. The particle system, so like release is a method on a particle system, but what's in this particle system table is an object, a class that we made that has a particle system in it. So if we look at the class, of like snow system, for example, the .p systems is actually the particle system. So we have to run the release method on the .p systems. So if the particle systems .p systems release, if there is no weather assignment in the map declarations, then we want to release the old particle system that used to be in there. So let's see. So we get snow on this scene, and then if we go, son of a, can't index a field P system. So it's like, it's the particle systems. The particle system index 1 has a .p system that we can run release function on. Cool. Son of a, cannot use object after it has been released. I guess I don't know what released really does. Because it's like, it's saying Snow System 47 is trying to do something. And Snow System 47 is just drawing it. So we're rendering it. Oh, we need to clear. I think we need to clear the scene's particle system once we release it, so that we don't try to do anything to it. Because we're updating it as long as it's not nil, but it is. Or yeah, we're releasing it. Or if we delete this, I think if we flush this out to be empty, then when we go to update it, it'll know it's nil, then it skips updating, so it doesn't try to update a released particle system. That's it. We didn't reinitialize it, but that did it. So look, we get a particle system here, and then it releases right on a begin transition. So we don't want that. We want it to release when it finishes transitioning. So okay, so instead of flushing this here, like the particle system release, this is the thing where I was talking about, where we needed to make a method to reinitialize this stuff, because once it's released, then when we try to go back into the scene in this begin shifting method, it's asking, okay, well, is there a weather thing in there? Which there is, because we put it in there. Then it's going to ask, where is our .weather? Yes, it says, okay, well, it's not nil, and the thing is equal to snow when we transition back into it. So therefore, let's insert into our scene's particle system a snow system, but this snow system is an object that we had already run the release on. So maybe release isn't the move. Maybe release isn't the move. Maybe we just turn off the emission rate. We would still need a method to like reinitialize the emission rate, but I would think that we wouldn't crash because it's not released anymore. So like maybe we just have we have to do this in a specific way for, it's called set emission rate. Okay, and the emission rate is a local thing here. We'd probably want it in the init so that we can reset it, but we want to run, we do it like this, where we say colon set emission rate, and let's keep release here just so we can see what it looks like. Now what we want to do is say, okay, well, we go into our particle system, and the thing we're trying to update upon a begin shifting is to just set the new emission rate. and we want to set it equal to 0 so that we are no longer spawning any particles if we walk into a scene that doesn't have any weather assigned to it. We want to just stop emitting particles. So we should get snow here, yes. And then the emission rate should go to 0 when we scene transition. Well, that looked... Oh! See, okay, yeah, it's disappearing right away. But, I mean, this is close, right? Like, this is cool. It's, yeah, we don't want it... We don't want the emission rate 0 on a begin shifting. We want it on a finish shifting. So... I think what we might want is... because this is in the... Yeah, this is in the begin shifting. So we basically want to say, well, this same idea, but once we finish shifting, we're going to see if the scene we're shifting into is nil. If it's not nil, so I guess we can say if it is nil, do this stuff. If the thing we're going into is nil and we're finishing shifting, go ahead and emission rate 0, which should turn off. We shouldn't see it only when we finish shifting, not when we begin shifting. So if we turn this off, hopefully we get something good. So there's the particle system. And then it turns off as we shift, which... You know, it's close, but it's like, it's not that we want an emission rate 0. You know, the emission rate 0 isn't what we want. If we turn off the emission rate 0, it should just keep emitting, right? No. So what are we doing? Well, oh. Well, we do flush the table, so that's what gets rid of it right away. Okay, so let's not flush the particle system because we're not clearing it anymore, and let's just set the emission rate to 0. We're not releasing the particle system, so we should be able to keep them there. So let's see. Okay, yeah, emission rate goes down, but are we not setting the emission rate to 0? Yeah, we are. Is there another thing in our particle system that is causing these things to spawn? I thought it was emission rate. Set emission area. Particle lifetime. Emission rate. Okay. Emission rate. If we finish shifting and the thing is equal to nil, which only one scene has a weather field. So most of the time when we're transitioning, it should just go into the particle system, into our scene, and just set its emission rate to 0. Let's see. So it's like emission rate is something here, and then when we shift to a thing with nil, the emission rate becomes 0. But we're still getting emitted particles. So something's wrong in it might be here in the, you know, we might not be doing, like, I guess let's try to just release this thing and see if we're in fact like targeting it, because we could just, there could be some other stuff we changed in the shifting logic. Okay, so it does look like it's targeting correctly. I guess let's maybe try emission rate. Yeah. That should be it. I guess if we look at our sand system, we have this init that is like this emission area and emission rate. Okay. Yeah, because I guess, you know, if we come in here and say, okay, well, emission rate is actually 0, we shouldn't see any snow particles. But we do. Okay, so emission rate isn't doing jack, right? Because that's the problem. So our scene, our emission rate for our sand isn't doing that. Let's test it for sand instead of snow and just see if we got the emission rate right on that. Because maybe that's just the only thing that's jacked up. Okay, so no, not here, not here. Right here. What we're gonna do is go insert sand into the thing above us. And then we're gonna say in our scene, when we do the old snow thing, we're gonna put our sand system instead into our scene's particle system. And then we're gonna set emission rate to 0 on the sand system. When we come back, when we scene transition into a thing without a system. Oh, see, look, we're not even seeing it. Well, we're doing snow here, so this should be sand. Okay, we should see sand when we come up here. Nice. And then when we come out, see, the emission rate should be 0. So we're setting it. Yeah, we're setting it. I must just like not be understanding emission rate correctly, I guess, because if we go into the sand system and we go to the set emission rate, and what we do is say that we're going to put 0 as the emission rate in the init, what happens? Nothing. Okay, so that's working better than the snow is. The snow renders the exact same no matter what emission rate we have. Because see, look, that's good. Because now, you know, that's only a little bit of sand. We put 10 sand instead of 8,000 or whatever. So the emission rate on here looks to be working. So that tells me that we should be able to, in a finish shifting, if the weather is... If by the time we finish shifting, we're shifting into a scene that doesn't have a weather string initialized, you know, it's nil, then we're going to set the emission rate to the scene's particle system, set the emission rate to 0 here. But we get sand nonetheless. Yeah. So the emission rate for the class is working, but this isn't for some reason. So like, let's try this again where we do it upon the begin shifting, where we say, okay, well, we're just going to set our emission rate here to 0. I think we want to clear the particle system table. I don't think we want to do that. Okay, so we've got sand. Yeah, it doesn't do it. Emission rate there. Huh. Let me just see if by the time we insert it, we're going to just dive right in and overwrite its emission rate to 0 and just see if it stops showing up. It doesn't. So I'm just fundamentally misunderstanding something here then. Because we're inserting into our particle system a sand system object. Then we're going into that particle system table, going into the only object that's in there, which is our sand system class. and we're going into the particle system in that sand system and saying set emission rate to 0. I thought this would work. Yeah, because this is working in the class itself, in the sand system, we can set this emission rate to whatever, and it works. So we're not re-initting this. You know, we can say get an emission rate of 20 in the init, and then we only have like 20 sands here. So the emission rate is working on that class. We know that. It's just that when we go to like, we must be, oh, this is in the update, not the init. That's the issue. We're updating. Yeah, that's it. So we don't want to update it. We want to initialize it. So we're going to set our emission rate to the default emission rate. But then when we finish shifting, we want to set the initial emission rate to 0 if we finish shifting into a scene that doesn't have a weather particle system. So we should see a lot of sand here when we go up. Nope. Emission rate. Where did our emission rate like 40 go that we put? Oh God. Here. This is actually emission rate. Yeah. Oh, we don't even want, yeah, we don't want that in the update. That's in the update. We have it right here. Yep, set as our local emission rate. So this should be a lot of sand. Cool. And then it should, let's see. Oh, dude, yes. Yes, now we need the methods to reset the initial emission rate. But that was perfect because it didn't cut it off right away. It just took off the emission rate. So by the time the particles died, then they ceased spawning, but they let their natural life cycle come out. So that's exactly what we want. So we don't want to clear the particle system because we're not releasing it. We just want to flush its emission rate to 0 to let them die out as they do. Now, this is like, you know, we're checking right now only for sand, which there's only one thing that has sand in it. But basically, if we go in and it is equal to sand, let me think this, because we have to reset the emission rate, right? So instead of setting it to 0 here, we would set it to whatever 8,000 emission rate or whatever that the sand was. Let me just see if this works for sand. Like, so we have a shitload of sand, they die out, perfect, and then we come in. Oh, yes, dude, yes, dude, that's it. Yeah, so like, you know, this isn't where the sand goes, but this is sick. So it's like the particle system exists in the scene and not the map, which gives us this smooth transition once we shift for it to exist outside. You know, it makes sense for the spellcast element particle system. Holy crap. Hey Orlin, thank you for the follow. That creeped me out. What up, Mage? How's it going? Cool. So you know, we need to make sure that our other particle system. Yo, Orland, hey, thank you for the Prime. I appreciate that. Yo, welcome in. We're trying to finish the demo. We're trying to get a demo out for playtesting at the end of this month, and this is the last feature we're putting in. So other than this, we're trying to, you know, we have to design the rest of like the overworld levels, but I'm basically happy with the content of the demo. I just need to kind of make it look prettier. So this particle system stuff we're working on is this particle system stuff we're working on is to kind of limit the the explorable scenes for the demo. So we've got 100 scenes to explore, but they're all kind of placeholder stuff for now. So we basically are doing this so that if we go into the sand area, that there'll be so much sand that you can't walk through it because you haven't unlocked that biome yet. So this is the kind of like particle system test to prevent the player from exploring too far into the sand ecosystem by the time they finish the first dungeon, because the first dungeon will spit you out over close to the desert, and then if they try to defer too far from there, they'll get stopped by the desert. So it's cool that this is working, but we need to get the snow working similarly, because the emission rate for the snow system isn't working like this. And then we can test the rain also, because if you go too far into the forest, it's going to be too rainy. If you go into, I don't know. I don't know if we'll do blizzard. I think sand might be the only particle system we see in the demo, because it doesn't make too much sense to me that if it's so rainy that you just can't walk. It makes sense, like a sandstorm makes sense that you couldn't walk because it's too sandy, but I don't think I don't think the rain is gonna stop. So it might be just sand. So I guess for now we'll continue with the sand. So I guess let's try to place it only in the right places. So this is a map 7.3. Let's see, where are we? 8.3, 8.4. We're looking for, yeah, okay. Let's try to put it just as like a proof of concept, because I also want to ramp it up, right? Like the very first frame you enter the desert, there's like half as much sand, and then as you go another scene into it, then it gets crazy, and then you can't walk very far. So if we do that here, this is what? Oh my gosh, 8.6, 8.7. Okay, so 8.7 is here. So it looks like 7.7 is the top of the desert. 7.7's the top. So everything to the right and down of 7.7 is a sand. And if it's a row or column of 7, then it's the initial sand. Anything deeper is like super sand. So let's try to do that. Now I don't like this like hard-coded 8,000, because it's like right now the system is kind of declared just with a string of sand, and we don't have a way of saying this is like baby sand or this is crazy sand, a lot of sand. So we either need to make a different option like light sand, medium sand, heavy sand, or something like that, and depending on that option sets at a different emission rate on a begin shifting, which could work, or we think about some other way to go about it. I think I like the light heavy deal. So like I guess what we can do, I don't want to hard code this 8,000 in the emission rate. So what I want to do is go into the sand system and say that this emission rate is actually it's actually going to be a field on the init. So instead of this local emission rate, see this 8,000, that's where we stole it from. Like I knew it was 8,000 because we did it there. But instead of it being a local variable, it's going to be a field on the actual sand system so that we can reset it. See, this is actually wrong too. This would be like initial emission rate or something like that. So the initial emission rate is this 8,000. And we want to initialize it to the initial emission rate. And then right here, when we go to set the emission rate, we want to set it based on its not its particle system, but its initial emission rate. So we're going to snag this and say that it is the particle systems dot initial emission rate. Okay, that should give us the 8,000, but it's a little cleaner because it's like, okay. So, and what we can do instead of this initial, if, you know, we want to put, if we look at our map declarations, we're going to say, well, you know what, there's going to be light sand and heavy sand. So for map 8.2, to test light sand instead of heavy, we're going to say, well, if this thing is equal to light sand instead, we're going to set it to initial light emission rate. And initial light emission rate is going to be defined in the init here as initial light emission rate. We're just going to cut it in half. We're going to see what 4,000 looks like. So initial light emission rate is 4,000 versus the normal emission rate, which is 8,000. And if it is light sand, which it is as we initialize it, we're going to give it the light sand emission rate, light emission rate in that particle system set emission rate. So let's see. We should have about half as much sand. That looks like a lot of sand. Let's see. 20, if we put 20, does it give us 20 here? Yeah, okay. So the initial light emission rate, initial light emission rate, let's just cut it down like a lot and see. 400, does that look like light sand? Okay, it does. It does. Okay, so 400 looks pretty good, but then we want it to get heavy sand here on this 7.2. So let's say that in 7.2 we're going to have the heavy sand, yeah. So in 7.2 we're going to have heavy sand, and in our begin shifting, in our scene method for begin shifting, we're going to say in our scene, when we're looking for light sand, you know, we check if it's light sand and we do a certain thing if it's light sand. But if it is heavy sand, we want to do a different emission rate set. So the emission rate set is going to be, well, yeah, we want to go ahead and do this, which is insert a sand system object, but we want to update that object to be a different emission rate depending on its option of light or heavy. And we'll have this as heavy emission rate, initial heavy emission rate. It's already set to something different, but we can just for like continuity, you know, initial heavy emission rate is going to be this 8,000. Okay, so we have two weather options in our scene. The first one we walk into should be light sand, which is 400 particles, and it should be 400. You know, that's light sand, but then it should transition into heavy sand here. And it does, yes. And then it should transition off here. Nice, dude. Yep, comes back to heavy there. Light here, nice. Oh, that looks so cool. And then nothing. Perfect, perfect. That's looking epic. Now it's still crashing, you know, if we go to a warp zone and come back, it crashes. At scene 145, I don't know why. Oh, it's actually, I don't know why, because it's like at 145, is that scene 145? That's right here. It just doesn't have a weather table for a map row. Okay, so we just need to initialize this. You know, upon a warp zone, I don't think we're updating our map row, map column on our scene. So on a warp zone, yeah, I don't think we're doing that on a warp zone. So like when we do a warp zone trigger, we have it's just called warp zones, I thought. Nope. Warp zones here. Okay, so once we do like a finish warp, oh my god, this is messy. See, like I would bet that we're not resetting our map row. Oh, we are. Huh. At least here we are. Map row. We do it if we're going into a refinery state. Map row, map call. Yes, so I think all we have to do to prevent that from crashing is just to assign our scenes map row, map call based on whatever we warped to, which is dependent on what the this current map. Oh god, man. We have a warp row warp call. That's what it is. Warp row warp call. So let's do our map row map call to be this warp row. God, say that 10 times fast. Set our scene views map row map call to be our warp zones map row map call. That's not right. Okay. We cycle through our warp zones. See this warp row. Is this a parameter being passed in? Where do we get this freaking warp row? Is a V on the warp zone object. Okay, so if we do a warp zone, if there is an active warp zone and we're not already warping, let's become warping. We set our warp object. What the fuck? Okay. Because, yeah, we just wanted an easy way to access that row. So what I'm going to do is, if we're warping... Oh, God. Really, dude? If we're warping, after we snag the warp object, we're going to say, okay, well... we need to set our scene views map row map call to be equal to the V's warp row warp call. God dang. Warp row warp call. Okay. That might fix the issue. If that doesn't fix it, we just got to do a bit of digging, because if we go into a warp and come out, we still crash. Shoot. Well, we can debug that. We can debug it. It's got to be something with that, because the particle system is generated based on the map row map call field, or map column field. Is that right? Map column. Yeah, map row map column field. Yeah. But even if this was like set to nil or something, it shouldn't it shouldn't crash because it knows if it's nil just to not update it, so it shouldn't crash. So I'm not too worried about figuring that out, but this is really cool. This is looking awesome. So I'm very happy with this. I think we'll call it a night here because we missed our commit for the day because it's past midnight, but that's okay. I think we will just say, let's check our git diff. Yeah, we basically just added a weather table to our global maps, and then we added a couple fields for different emission rates in our sand system, and then we trigger our sand system into a particle system on our scene class, and we're just kind of toggling the emission rates based on the global weather strings. It's just a string, light sand, heavy sand, and we know what emission rate to set it based on the value that's in the weather table if it's not nil. So that's essentially all we did, and it's working, other than if we go to a warp zone and come back, it's breaking. But I'm not too worried about that. I think we'll figure it out pretty easy. So I think tomorrow once we finish, hopefully tomorrow we fix this warp zone bug so that it just works. Then we can go and actually put it in the desert for now, at least as like a placeholder, because desert isn't like permanently locked down for the demo just yet. Because I don't know which actual scene we pop out of the dungeon, because we get to decide that with the warp zone. So I get to kind of decide which scene exactly we want to pop out, where we want the shortcut to be set for pushing the boulder out of the way. We're going to put a little meditation idol outside of the dungeon so you can save your progress right outside. Maybe we'll put an inn there also, and that's where it's going to be. We have to put our treasure chest with the first tome in there, which isn't that bad. We've got a treasure chest class. We know how to put things inside it. So we do need to add the conditional rendering for the tomes that are unlocked, and then also set the Guitar Hero minigame to actually apply only if the tome is equipped. So there is like a lot of little stuff to put in there on top of actually designing the overworld better. But we got the conditional particle system depending on the map location. So that's a good step. So what we're gonna say, add weather particle system for particular maps, light sand and heavy sand. Git push. Sweet. So with that, we'll call it a night. We'll run credits here. We'll find someone to raid out to. Let's see if Salto is still streaming. Salto streaming? Salto's streaming. Okay. We'll raid out to Salto. He did the art for the game in the background here, so I always like raiding him and giving him some attention after I'm done streaming. So I'll call it a night. Thanks for watching, y'all. Thanks for the sub mage. I really appreciate that today. And I'll be back tomorrow with some more programming.